Central Asia stands at a pivotal moment, balancing the scars of past industrial practices with the promise of a sustainable future. This session will explore how the region can shift toward responsible mining, integrating low-carbon technologies, ESG principles, and innovative remediation strategies. From tackling water and waste management to implementing circular economy models, experts will present practical solutions for restoring ecosystems and ensuring long-term stakeholder engagement. As the world moves toward greener industrial standards, aligning project development with investor expectations and community well-being has never been more critical. Let's explore how Central Asia can lead the way in responsible resource management.
Thank you, ladies and gentlemen, for attending this session. I'm sure it's going to be a very insightful one, and it's very topical at this point in time, as Uzbekistan and the Central Asia region is one of the most climate-sensitive regions in the world. There is increasing pressure on water resources, brought sharply into focus by the construction of the Kosh-Tepe Canal, which is predicted to divert 20 to 30% of the flow of the Amur Darya River. Mining operations across the region are dependent on regional aquifers, which need to be carefully managed to support competing industries and an increasing population. Other constraints on the sector include human resources and qualified personnel. It is of high importance that the sector combats health and safety perceptions that have detracted from encouraging the brightest young minds from entering our sector. In Uzbekistan, mining also occurs in densely populated areas, close to legacy mines and mine waste facilities. There is increased pressure from governments and financing partners to ensure expansion of the mining industry does not negatively impact our natural resources, other industries, and stakeholders. And with that, I would like to introduce the first speaker for this session, which is Mr. Vyacheslav Sisyan. He is Deputy Director General of the State Ecological Expertise Center and Ministry of Ecology, Environmental Protection and Climate Change for the Republic of Uzbekistan. Mr. Sisyan.
Good afternoon, dear participants of this seminar. First of all, I would like to show gratitude for organization this forum. It is well organized, and today actually it is very important for Uzbekistan. Is a mining sector and mining industry, and with the geological exploration and other geological work. And we of course must have balance between ecological sustainability and industry development of our country. Also, I would like to say that how this interconnectivity of the Ministry of Ecology with the Ministry of Geology and other branches of businesses, we are trying to have a balance here. So tomorrow, after our mining activities, we will have favorable environmental conditions, and also there will be restoration of the land after the land degradation, like land rehabilitation, land reclamation. It's very important, the environmental restoration. And for the recent years, our government is very carefully paying attention to the issues of ecology, and different programs by the decree of president. That annually there is recultivation of land and rehabilitation land. Like annually in 2024, it was planned around 200 to 2,000 hectares for recultivation work, which is actually being completed. And with that, of course, we should never stop. We must always move forward, because this work, which is the majority of like already destroyed land, we must take some measures with shareholders, ministries, and entities, and really work on degraded land and recultivated land. In 2023, there was a moratorium for this work in a river, like a big river of our country, Srdarya Mudarya Cherchik, and by initiative of our president, the degree was signed on degradation of work in Cherchik River. And Cherchik River, as all of us maybe know, it became, like, because of non-systematical approach of work, it became like lack of water, and now you can really see it when you cross the bridges. You can see the result of these works. And also, I would like to note that this year there is recultivation being planned, more than 2,000 hectares of land, and during different mining and other works. An important direction is rehabilitation of land, like, along the river, not only Cherchik River, but other rivers as well on the territory of Uzbekistan. Particularly, it is important in the climate change and different threats, erosion and floods. You can see in the world there is a climate change all over the world, and it is connected to different nature cataclysms, natural catastrophes. That's why the work which being planned, we are waiting for other results. Rehabilitation of 120 hectares of the river borders territories, and also the moving these decorated trees from this territory, also to clean and to restore the destroyed part, like by the rivers, and also the to have the analysis and monitoring of this work. I also wanted to know that today, according to the initiative of Ministry of Ecology, alongside with international entities, on automatized monitoring, and to see this the stock of the rivers. What it is about? It is there are about posts which are under control of hydrological services under the Ministry of Ecology. Every day, it is being it is being controlled for the stock of water, because we can say that we have transborder rivers, Srdarya and Amudarya, and we also have, particularly with the bordering with Kazakhstan, agreement on not polluting the Srdarya river. Together with their services, every quarter we have analysis of water. Then, in case of some decline, they have a specific team who is operatively can detect the source of pollution, and also to put into compliance according to the measures and this agreement which I mentioned above, on the quality of water. I also wanted to know, dear participants, that the future of mining industry is not technology and responsibility, but also we must go from the model to extract and go to the extract and restore, because it's not only about just extraction, but we need to restore always, so it will not be threatened by erosion and other changes of the content. It will not have the degradation of deserting. And of course, it takes a political will, investment, scientific approach, and of course, a regional cooperation. In conclusion, I would like to share the words that the journey to the ecological sustainability, it will be supported not only by initiatives but real activities. Only this way we can really create a harmony for prosperity of our nations and citizens. Thank you very much.
So our next speaker is Sam Safavian. He's a technical director from SLR Consulting, specialising in risk-based dam safety assessments. And that's what his topic is that he will speak on today.
Hello, everyone. Thank you very much for your attendance. The topic of this presentation is just transforming liability into a strategy. And we will discuss how a risk-based approach to tailings dam safety help the mine owners to protect their asset, reputation, societies, and the environment more efficiently. So, due to the importance of this matter, we will try to just discuss the concept at the beginning, and then at the end, we will just review a case study together to just have a better understanding of this new approach. So, most of you have heard about this disaster in 2019, Brumadinho Dam in Brazil, which killed 272 people and flattened the entire village and damaged the environment. So, as a result, GISTM was developed, and was developed in response to the society expectation that the mining industry needs to do more to prevent such a catastrophic failures. So after that, until now, we had another 33 failures, which means we haven't done enough. If we just followed the risk approach, if we could analyze, evaluate, and eventually mitigate the intolerable risks, probably we could just prevent many of them. So, but before we start, we should know what's the difference between risk-based assessment and standard-based assessment. Standard-based assessment is a traditional approach. It's like a normal health check. As long as all of the boxes are ticked, there's no problem. So it is good for the new designs that we should just satisfy all of the criteria. For instance, safety factors of the stability and different other criteria. But the problem starts when some boxes are not ticked. And it is not possible to cure all of the problems at once, because always budget and time, we have limitation in budget and time. So that's when the risk-based approach is very important. And we should prioritize the actions to mitigate the risk. So I'll quickly go through the process of the risk-based approach. The same as all other projects, we should start with the gap analysis, see what information we have, what information we don't. Starting with the investigations. So doing some site investigation if we need more information about the ground, topography survey, hydrology assessment, dam break assessment, consequence category assessment. Then we should just do some stability and liquefaction assessment if we don't have enough information, numerical analysis, and eventually piping assessment. At the same time, we should do the failure mode assessment, which I will discuss it later more in detail. And the next step would be the assessment or estimation of the probability of the failure. And it has different steps, starting with the assessment of the conditional probability of failure, then probability of the different loading conditions, then we should just combine all together and just define the annual probability of the failure. And the next step would be the risk analysis and risk evaluation and developing the risk profile of the project. So, for instance, if this project was based on the anchored guidelines, if the risk profile of the project, if it passed the threshold line, it means we should reduce the risk no matter what the cost and budget is. And we should just provide some mitigation options, do all of these steps again to just get to the satisfy this criteria. So, but the first and the most important step in the risk assessment is a failure modes and effects assessment. I quickly go through it, considering the time limitation. The purpose of the FMEA is to identify all of the potential failure modes and to decide which failure modes are credible and to develop all potential failure paths and mechanisms. For instance, in one of the projects that I'm going to just discuss, it's a case study that I want to discuss. We had around 50 plus 50 failure modes, and we screened out more than 45 of them, and we ended up just going with the 5 credible failure modes. A credible failure mode should have credible initiating event, and it should have a credible failure path, which lead to the breach of the facility. And the different steps are hazard assessment, system identification, failure modes analysis, and failure modes pathway. All of these steps should be undertaken and should be reviewed by a panel of experienced engineers. So these are 2 examples of the failure pathways. So internal erosion is one of the important reasons for the failure of the facilities. And based on the study was undertaken in 2010, it was the first engineering reason since 1900 until now, and the second reason of the failure of the facilities. But it has been overlooked, and generally been overlooked even right now. And what is the piping failure mode? So it starts with initiation of the erosion, which could be through a crack in the embankment or a high permeable zone in the embankment. And it continues and progress. And then eventually, if you can intervene, it would lead to the breach, partial instability, overtopping, and breach of the facility. Again, Bromagino, one of the possible scenarios for the failure of Bromagino was that it started with initial erosion, which led to this weakening of the structure and a strength softening of the tailings structure, which led to the liquefaction, static liquefaction and rapid subsidence, and eventually led to the slow instability and full breach of the facility. So for piping assessment, we generally follow piping toolbox for quantitative piping assessment. Originally, it is a systematic method for estimating the conditional probability of internal erosion and piping and embankment dams and their foundations using the inventory approach, and originally developed by USBR, but later developed further in collaboration with US Army, URS, and University of New South Wales in Australia. So, and it is an example, a general example of the inventory approach for piping assessment and general inventory approach. So now we are going to discuss this case study, and which in this case study we evaluated the associated risk posed by a TSF. It was around 40 to 50 meters high, and previously the standard-based assessment was undertaken for this project, and we determined whether the facility meets the tolerable risk criteria, and if not, how to mitigate the risks. And in conclusion, we wanted to conclude that defining the risk profile of the project would help the mine owners to proceed with the best upgrade option to mitigate their risk more efficiently. So the same, we started with failure mode assessments. We ended up with 5 credible failure modes: instability of the embankment due to liquefaction, downstream embankment instability due to flood loading, piping initiated by transverse cracking in the embankment, known as IM7 in the piping toolbox, and IM14, piping initiated by continuous high permeability layer in the embankment, and eventually failure due to scour erosion because of overtopping. And this is an example of the failure pathway that I mentioned earlier. So at the same time, we did the Amberg assessment for this project under a separate agreement, which is not the focus of this presentation, but we need the results. The incremental PLL and PAR is shown in this table. And just I should say that the incremental refer to the additional or increased risk of loss of life that occurs due to the failure of the dam compared to a scenario where the dam doesn't fail. So what is then we just estimated the conditional probability of failure for credible failure modes. And this is the example of the event tree that we developed. And after that stage, we need to just develop the system response curve, which is a relationship between the loading event and the likelihood that events. And we should just develop this for each of the credible failure modes. We did the same for all of the credible failure modes, including the pipe. And eventually, we need to use this system response curve to develop the event trees and to assess the risk of the project. So, and then later, just we needed to just define and estimate the annual probability of failure at this stage, because I'm running out of time. I'll just skip this section and just eventually we assess the annual probability of failure by combining the probability of the partition, loading partition, and the conditional probabilities of the failure for different failure modes. And in this assessment, we realized that ST1E, which is the instability due to liquefaction, is responsible for 70% of the failure, and piping IM14 is responsible for 17% of the probability of failure. And the next stage was risk assessment and risk evaluation, developing the risk profile of the project. We had the consequence part of the risk. Now we just assess the probability part of the risk. So we have two legs or two components of the risk, and we combine these two components. And eventually, in this pie chart, the contribution of SD1A is 63% to the total risk to the society, which is 5.5 times 10 to the power of -5. And again, IM14 is the next one, and then instability due to the flood is the third one. And eventually, we developed the risk profile of the project, which is well below the threshold line. And so the FN chart shows that the level of the societal risk posed by the project is below the specified safety thresholds by more than an order of magnitude based on anchored guidelines. And thank you very much for your time. Sorry, I'm a little bit just running out because I was prepared for 15 minutes, then something happened. Thank you very much.
Thank you, sir. Next up, we have Ed Austin, who's a principal hydrogeologist for SLR Consulting. And he will be talking on the benefits of improving mine water management practices.
Yeah, hello everyone. So, so basically putting this talk together, I was thinking about the session themes, and obviously water management is a big part of the session themes. I'm going to be talking about some practical solutions, a little bit about the expectations in project development, and I'll run through some examples, and so hopefully some of these will be a good range, looking at some of the local issues, site-wide issues, and then looking a bit more at the regional scale. And I'm going to go through roughly 7 examples: demand, harvesting, some more tailings, some discussion of groundwater inflows, operation and collaboration. So example number 1. So this is an example of a water demand management study. So basically I included this example, so water stressed sites, maybe it's similar to some places here, and the operator was importing water. Obviously this costs money. prevailing perception on site, we're in a very dry area, there's no rainfall. And if you look at the precipitation stats, you can see, there's high evaporation, but the mean annual is 300, but there's a lot of variation around that number. So there is an opportunity there to reduce your water import. So for the study, basically went through a process of information review and a site visit and look around site, where are the opportunities for these improvements? Take that information into a water balance model, software called GoldSim, and basically you can undertake a pretty basic cost-benefit analysis, and you can make some decisions by looking at your payback period, basically a CapEx versus the OpEx. So you're basically looking, you can see the illustration by the figure, import cost money, water that comes out of the sky is kind of cheaper or nearly free. So the example in relation to this, again, stormwater harvesting. You can see from the pictures the mine water management ponds were leaking, a lot of evaporation as well, so there's seepage loss, and the dams and the pumping system, they weren't up to the job, basically. So that's the observation. The improvements, okay, so we increase the capacity. It's simple, right? We line the dams so they don't leak as much. We improve the pumping so we can have more return water. The benefits for this case was 5% reduction in the supplied water on average. So that's the OpEx cost reduced. And the payback period in relation to that, getting your money back on your CapEx investment for improving the system is 10 years. So it's a long payback period, so you need to do these things preferably at the start of your life of mine, not later on. And obviously the environmental benefit, the management is improved generally. Let's not forget this, it's contained and managed properly, there's no seepage and leakage. Okay, number 3, tailings facility. Look, we've had some discussion from Sam. Reducing seepage and evaporation. Again, losses from an unlined facility. Large pond promotes a lot of evaporation loss. Low density tailings. So the improvements, okay, it's obvious again, we reduce the pond. We increase the capacity of the decant. We adjust the return water pump. We go for a shallower pond. Upgrade the thickness so there's less water in the tailings in the first place. The benefits, again, you can see a 15% reduction in supplied water, so you're saving money on your import costs. 5-year payback period. This one is a better payback period, it's shorter. And again, the obvious benefit is seepage and plume impacts are reduced. Okay, and you can see I've tried to illustrate there, the different features. Example number 4, tailings facility again. Failure risk, we've had some discussion about this today. So reducing failure risk and reduce water loss at the same time. So a lot of facilities, no secondary storage. The water is stored on the facility. Sometimes all on an upstream raised facility. Maybe for some of you this will start to ring alarm bells. Heavy rainfall in the area, again, we know the story. Storing water on a dam, this is a high risk, but for the operator, they're in a difficult position. Hobson's choice, what are you going to do? Store it on a dam or discharge all this water to the environment? Maybe you'll have a compliance breach, maybe you'll risk a fine. So the improvements, you build a downstream return water dam, preferably lined. You increase the capacity of your system again, of your decant. You reduce your point volume and increase your freeboard and improve your consolidation. Okay, simple steps to make. Benefits, your likelihood of failure is reduced, as we've seen from Sam's talk, the different failure scenarios. Your reduction in the consequence of the failure, there's less water on the dam if it fails. It should reduce the consequence. And this change in consequence, this could lower your insurance premiums. Excuse me. The next slide, this one just shows that picture. It's enlarged so you can see it better. You can see, look, you're taking the decant water to a return water dam. Now you have the option, rather than accumulating on the dam or discharging to the environment, perhaps in an uncontrolled manner. Number 5, groundwater inflows, my favourite. I'm a hydrogeologist. This one is all about reducing contact water volume. Observations, inflows become contact and they accumulate sediment. In a lot of situations, perhaps you don't need active or advanced dewatering wells to promote your slope stability. So you can let it just seep into the mine and pick up a load of sediment. This sediment load is difficult to manage. It takes up footprint, it takes up resources. It leads to a poorer water quality. This is not good for you. Okay, so the improvements, you can opt to capture as much as you can. Usually you can get about 70% via holes or wells. It becomes non-contact water. It doesn't have sediment or has less sediment. And then you manage and convey that water as non-contact water in a parallel system. The benefits, you improve your quality. That water is now readily available for you to do more with that water. It can go where you like. You're increasing the lifetime of your infrastructure. There's less wear on the infrastructure. It's not getting grounded down by all the sediment. You're spending less on your treatment, and you're spending less on your dealing with your wastes and your sediments. Oh, excuse me, back one. Number 6. Okay, assessment and design and operation. We need to link feasibility and operation. There's a big irony. Basically, you spend a lot of money in feasibility studies, get the data, make the design, understand the design, spending the money to have a solid design basis. Feasibility is done, you go to operation. Many times you see that falls away. It is all there, the data is the real data, the real life is there to be captured, and it does not get picked up. Okay, so usually what you find in investor institutional reviews come in and it's inadequate for this reason. The project is carrying risk through its life, and we see this thing, the investment and effort is in peaks. Feasibility, maybe later on you make an expansion, okay, let's get more data again. So the improvements is make some guidelines so that you collect data through the life mine. Front load your investment at the start of mining, so it's all set up to capture. Use that operational data to inform yourself. Regular review and update. Go from a reactive scenario to making expansions and improvements to just, it's part of your everyday life. Self-permit yourself, are you doing the right thing? Are you operating as intended? The benefits of that, you'll be ready for your next phases. You won't have a mountain to climb in water management when you want to move forward. And obviously, of course, it supports your ESG. And you're on a better footing all around, and it improves the confidence, as I already said. So, and again, the illustration here is just of the water balance. You'd be surprised how many times you look in and it's just not there, the detail, okay? Number 7, this is a bit more of a regional basis. More and more in the UK, we see this coming more of a thing. UK, yes, it has some water stresses, not the same as here. So we see a lot more collaboration, a lot more data sharing, a lot more expectation from the authorities and regulators that you will be doing this with your neighbours. Okay, so you have the stress of the region, you've got several resource operators, perhaps you miners and other water users are there, one catchment, one district. Okay, the regulator has the hard choice. They have to regulate the water pressures, the water shortages, and they have to hand out the licenses to abstract, and they have to make the environmental assessments. And sometimes they have to put in the conditions of the licenses that there will be hands-off conditions when you will not be allowed to take water. So the improvements to get around this, data and information sharing, make groups, share your knowledge. Perhaps you would make a regional groundwater model, perhaps you make a regional catchment model, perhaps you want to share infrastructure and cost. You basically want to arm the regulatory authorities, give them the information they need to permit your site, essentially. So the benefits, again, reliable and accessible storage. Perhaps you can club together and build a storage together. Basically, it informs your decision basis, gives confidence, trust and cooperation. And I see that operators really have to be a part of these solutions. So I'm just out of time, so I'm going to run through my summary very quickly. My summary then is the project site really dry? What can you do? Cost, benefit and payback. Get in early, it's a long-term game. Good water management is good business. Benefits for risk, but also the environment, ESG, we've spoken about, it supports that. Every site has improvements. Every site can be improved. Water is a common risk for everybody, and these challenges, like I said in the last example, some of these solutions are bigger than one organisation. Okay, thank you very much.
Thank you, Ed. Our next speaker is Alexei Ragun. He's the Managing Director for Kazakhstan of Patterson & Cook, and he will be talking through ESG improvements through tailings thickening and water conservation technologies. Thank you, Alex.
Thank you.
Alexei. Hello, dear participants. My name is Alexei Ragulin. I represent company Prioritised Group. So wonderful that professionals in mining can get together this year to discuss different areas and share experience. I would like to thank the organizers for the opportunity to be here and for the very pleasant, working, very friendly environment, which I think is very important. Let me present to your attention my presentation, which is entitled Improving in ESG, Thickening Tailings and Saving of Water Resources. My presentation is going to consist of the following items. First of all, we're going to talk about the general conditions and advantages in ESG. Then we will get ourselves familiar in technology of thickening the tailings. Then we will talk about transportation. Then we will talk about transportation. We'll talk about sample project and example of Minera Escondida mine in Chile and make conclusions. Let's start from the general conditions like environmental pollution. Tailings often contain heavy metals which can end up in nearby water bodies. This disrupts aquatic flora and fauna, pollutes the thinning of drinking water. We have risks of breaking the dams. It can cause flooding that destroy surrounding areas, destroy homes, and cause deaths of people who live nearby.
Further, inefficient use of processed water. A lot of water remains in the tailings or is lost and needs to be replenished, which requires significant annual water intake for mining enterprises. Also, the tailing management, it also can consider risk, its reputational risk, financial risk, and even the risk of revocation of a work license as a law. So if there will be a big problem in tailings dam, then the real situation can be that the company will be closed. And really the management of this tailing dam can really help in this issue. So, what is the tail thickening technology is about? I will try to make it easier. So, the thickening is the process by which a mixture of solid and liquids called tailings is dehydrated, resulting in a higher concentration of solids in the mixture. This process reduces the volume of tailings and the amount of water in them, making them easier to handle and dispose of. So, which improvements we can have with this technology? First of all, is flocculation, and flocculation is the process of a mixture and to making these molecules bigger with other, and these mining enterprises, the flocculation can really make the save the water and also to provide ecological safety. And secondly, feed like optimization, the thickeners. By other words, we can make an example with cooking the flour. If we put too much flour when we make this dough, it will be more thickening. If we will put less flour, then the dough will be like too liquid and it's not. So we must really put amount to achieve results. The types of thickeners, it can be high speed and high density and pastes. Traditional technology compared to high-speed technology. In this slide, you can see the compare with the high-speed thickeners with ordinary thickeners. And here you can see from the engineer standpoint of view and estimation, the square of these ordinary thickeners, it's twice with the high speed. Then you can see the speed of this is higher than 5 till 15 times. So the efficiency is very high. But the most interesting thing that the spend of flocculants and these with the same speed is equal. That's how it looks in real life. If the high-speed thickeners, it's more, it's very small, it's ecological, and it doesn't require a lot of cost on exploitation. Then we will look to tail thickening technology.
We have okay, 15 minutes or 10 minutes. Okay, thanks.
And the tail thickening technology, and there are important processes we have, and it is important to keep the order. The first one is the second. The second one is supply valve, the regulation of supply density. Then the third step is additional flow transmission, uniform distribution of feed using the entire surface area. Then pedaling, move the pulp to the center of the thickener, and the higher density is achieved by using frames, pickets, when it's moving inside on the thicker. Can we actually show very short video? So this is it looks like the thickening tailings. You can see the consistency. It's quite tight. Then when we put tailings to the appropriate processes, then we need to transport them, and there are a lot of conditions we must take into consideration of in pump transportation technology. Rheology is directly related to condensation and pump transportation, and the rheological properties of the material, such as viscosity and behavior during shear liquefaction of thickening, are crucial for the design of efficient pumping systems and processes involving thickening. There are centrifugal pumps which are being applied for high flow and volume at low pressure, and pressure piston pumps for low flow volume at a high pressure. Materials of pipelines used for transportation of ore, pulp, and tailings. It can be the types of materials are steel, carbon, stainless, and alloy, or it can be high density polyethylene, or internal coatings like polyurethane, HDPE, and ceramics. Also very important to take into consideration the wear accounting. All materials in contact with the pulp are subject to wear. It is important to know the characteristics of the pulp. Let's just see one example, project example, general data you can see on the slide. It's a high performance enterprise, 40 million tons per year or 5,000 tons per hour. Tailings of gold bearing or extraction with a pulp concentration of 35% mass, solid particle density 2.7 ton cubometers, total pulp volume more than 11,000 per hour, and 9,000 is water. Large tailing storage facility, more than 5,000 hectares, and located 40 kilometers from the processing plant, OP. And the hydrostatic pressure from the OP to the tailings dam is 350 meters, and bulk tailings storage along the perimeter of the tailings storage facility, and additional recycled water is supplied back to the factory or plant. Then several options depending on the amount of thickeners. The largest thickeners in the world today are 130 millimeters high speed, limited by the drive. It's technically difficult if it's above the limit, and usually several small units are used for this volume, and the size is determined based on two factors. Actually, I'm very lack of time, so there are two factors: SLR and RR, lifting speed and solid particle loading rate. And for this volume, we need to use three thickeners with a diameter of 60 meters, and the main criteria is an even distribution. The separation of water in the thickener. The separation of water in the thickener is about 50%. What does it mean for enterprises? This volume of water, first of all, will not flow to the recycling water pumping station. There will be no losses when it evaporates, and will not be stored in tailings dump, also mitigating the risk. The preliminary hydraulic assessment, as we already said, the tailings is quite far, a distance about 40 kilometers. The pipeline selection was chosen a diameter 900 millimeters within a rubber coating. The throughput capacity of 5,000 tons per hour at a solid particle concentration of 58% in mass. So what is also important, there is opportunity to the possibility of operation by gravity, so gravity flow for tails. The pump will be used only for taking water in. Then the water balance comparison analysis. So the water in the pulp without thickening and with thickening or condensation, it's the deviation in 39%. Because of this condensation, this volume is reduced by 39%. And the water reused in a factory is also water in the tailings dam supplied back to the total volume water consumption by 24. So we can say that for 45 million cubic meters, the water being saved. From the point of energetic balance, the total energy consumption is reduced to 40%, more than 5,000 kilowatt, and also the economy is 3.8 million of dollars annually. It's a safe cost. Very short example of the Minera Escondida mine, Chile. It's the biggest mine, largest copper mine located in Atacama Desert in Chile. The mine is joint venture between BHP, Rio Tinto, and Japan's JECO. And also, the mine's tailings storage facility is designed to minimize its impact on the environmental science in accordance with the GSM, Global Industry Standard for Tailings Management, and that's how it looks from the satellite. An example of the miner Escondida, it's capacity of 140 million tons per year. So in this video, you can see an example, discharge of ultra thin tailings from the thickeners into the transfer hopper. Here you can see how technology is working. We can see the consistency of the tailings is quite condensed. And conclusions. Condensation provides opportunities to reduce water and energy consumption, especially for high productivity mines. It helps to reduce the cost of tailings storage, processing, and disposal. Advantages of ESG, environmental, social, and governance, include application of industry best practices and compliance with the global industry standard for tailings management. It is reducing environmental impact because less water is used and less electricity is used. Also reduces business risks associated with water shortages, which is very important for Central Asian region countries, and reduces the amount of water storage in the tailings tank, extends the life of the tailings tank, and improves operational efficiency. The technology of thickening the tailing technology, it is efficient and economically very interesting technology. From our side, for mining industry of Uzbekistan, we offer to take into consideration this technology, which in our opinion will really give improved operational efficiency of your enterprises. And when we start cooperating with you, then you will have these benefits. I'm glad to reply to your questions during session or via electronic email. Thank you very much for your attention.
Thank you very much, Alexei. Our next speaker is Victor Davidov. He is the director of Ensor Management Consultants, specializing in environmental and social consulting. And the title of his presentation is The Development and Implementation of Efficient Environmental and Social Management Systems in Mining and Metal Companies. Thank you, Victor.
Sorry about this. Thank you.
Спасибо большое.
Участники форума идеи.
Dear forum participants, I'm very glad to see all of you.
Сегодня мы хотим
Today I would like to talk
системном управлении
about the
экологическими
system
вопросами в соответствии
management,
с практикой.
and I will also share the best practices.
Для начала я
At the beginning, I think
все согласятся с
all
тем,
of us will agree that for mining industry, eco-social problems playing
очень важно
very important role.
доказательства
And the evidences for these periodical ecological and social incidents which are happening in different locations in the world. And here, the previous speakers also shared a few examples. Also, like very similar or different kind of incidents are happening in Central Asian countries.
с вами помним
We remember, for example, in 2023, the Kostenko mining, where 48 employees they died because the methane bombs, and it was one of the trigger when the company ArcelorMittal it left this country. In other countries also, there are different kind of incidents happening and problems. For example, in Kyrgyzstan,
наследие
the inheritance of production of zinc ores, it still has the footprint, and it is affecting quality of life of local citizens, and it also gives some difficulties. And of course, it's the reason behind it is systematical mistakes. It's mistakes in the system, and usually very often they find like one person to blame, but actually, being honest, the problem is in the system. And one scientist in the system management, he said that the bad system will always win good person, and you cannot disagree with it.
если
And
говорить
if we talk about the importance of management system and what the system is about, it's a set of procedures and practical measures, the observance and implementation of which ensures the achievement of the goals of the organization. And the purpose of the SM is to ensure that the necessary policies and procedures are in place, as well as their continuous application by employees. The management system helps to assess and control risk, and it is the key to business sustainability. And one of the most important aspects, and as many of us know, it's about the cycle of damming. It's a cycle of continuous improvement. Do, check, act, and plan. And this is important aspects. It's real organism. When we talk about the management system, and I think many of you are aware and you work with this, when we talk about the system, a lot of people have imagination. ISO, International Organization for Standardization. A lot of people are very well know with quality management system, environmental management systems, occupational health and safety management systems, energy management systems are very popular right now, and anti-corruption management systems. But I want to say that in mining sector, mining industry, you cannot be limited just by ISO. And if someone tells you that let us integrate the management system and then we will close all ecological and social issues, it is not true. Fully. And besides ISO, of course, ISO, they have a lot of standards which are more famous, less famous. There are risk management, 31,000 and also social responsibility 26,000, and also maybe you can say let us certify for this standards, but this is just guidelines, you cannot certify it. And also there are very good standard SA 8000, and they are about social responsibility, and actually they cover a lot of aspects, the social block issues, and it also can be applied in mining sector, but it's less popular, let's say this way. And if we talk about the mining sector, what we talk about ecological and social issues and how we really manage them. Here in the slide you can see topics or issues from international standard AGMP, responsible gold mining principles, and it's about gold mining. And there are some companies which are successfully apply these standards, including Uzbekistan is MGMK, and we can see here in color highlighted which topics are actually covered by ISO. It's actually only 4 standards. You can see that only small amount of issues are covered by ISO standards, and very often we do audit for international financial entities or for the companies which are looking for financing and they would like to go to IPO and attract financing. And when we actually assess the management system, they say everything is good. Because we have the ISO standards, we have certification, but then we must dig in depth. How the issue of, let's say, that taking the lens like social question, how you have issue with the legal rights, with the climate, with the biodiversity and others. So
That's why the system of managing environmental social issues must cover broader range of issues. And here, with more details, I presented some examples of cases from more popular standards like SCMM and responsible, which are being united into a single standard. No standard has a requirement that you must have a comprehensive system of ESG. You can manage some parts, have separate system. Main thing it would meet requirements of main components for the system and work well. SCMM has special guidelines for every aspect, like biodiversity, climate, energy efficiency, and there's an example. We spoke a lot about it. TMS, Tail Management, Tailings Management System. It's a system which must be integrated with other systems, for example, water usage system, because it's very closely connected. So integration and relation with other matters is very important. If we are talking about companies that seek for international funding from international financial institutions, we need to pay attention to IFC standards. Special standard is dedicated to ESG system. These are the components of the same on ISO. There are 7 of them. That's a benchmark, but that's ISO. I wanted to talk more about IFC standards because they were developed especially for and targeted for the matters of ESG. There are 9 of them. Policies or obligations of the companies that it undertakes must cover all the components relevant for the enterprise. Risk and impact assessment, which is the basis, a cornerstone to build an effective management system, because without assessing risks and impact, we don't know how and what we are going to manage.
Это программа управления.
Third component is the management program, which is implemented after this assessment. Next one is the structure, which must be there, and the people as well, their competence. It's not possible just to have procedures on paper without competent experts in the internal primarily and external. Readiness to emergency situations. There are some examples about special thing is relations with the stakeholders, and I mean broad range of stakeholders, including regulators and investors and local population and employees and company management, and there are many of them. They must be identified. Complaints related mechanisms like application review, regular reporting to stakeholders, how the company is accountable to ESG. And the final thing is monitoring and review. Like a banning cycle, we must regularly check our system and bring corrections and constantly improve it. And in conclusion, you see a small questionnaire. I recommend everybody who represents companies here in mining sector use this questionnaire for self-assessment to see what stage of implementation, availability of management system that requires international standards and international standards, which stage you are at. You'll get presentations. This is in Russian, and you'll get English as well. Thank you very much.
Thank you very much. Our next speaker is Monica Goldstein. She's the Commercial Director for GeoSupport, and her presentation is on geotechnical monitoring as part of the mining safety ecosystem. A very important topic for all of us, I'm sure. Thank you, Monica.
Hello, dear colleagues. I would also like to introduce myself. My name is Monica. I represent company GeoSupport Russia and GeoTix Kazakhstan. We have a rep office in Kazakhstan, and we're actively working on territory of both Russia and CIS. Geotechnical monitoring industry is actively growing industry. Now we have many companies and experts, different equipment, and I should say that it has not always been the case. Let's take a look what's actually helped our industry to grow up to date.
Разобралась. Спасибо. Сегодня мы уже показывали несколько
We actually were showing a number of cases that happened in different countries, and that's one of them. That's United States. You can see this, the stats. That's how it looks like.
Видимо, не разобралась, почему.
I definitely need help with the remote.
Да, собственно, вот так выглядела
But that's how the accident looked like, which happened in 1213. A bit closer look. In this case, this slide happened. There were no fatalities, but lots of equipment and buildings were ruined. Brazil, Someone mentioned about it earlier today, but let's take a look how it happened. Let's please turn on the video.
Безусловно, говорить о том, что там можно было спастись,
Well,
практически невозможно.
it's not possible to say it could be people were saved. 272 people died. Company rating went deep, deep down. What must be mentioned is that we see those expenditures that companies spent and the cost occurred. That's just the tip of the iceberg. There were many costs that were not calculated for the things that company will have to face later. And as an example, many young people will be not ready to come to work for this company and will not be even willing to train in mining. And that's one of the key problems today. As a response in the world community, we established a geotechnical monitoring center called VAIL. It actively works worldwide, and I would like to draw your attention that as the main tool which is currently used in VAIL, these are georadars. Total number is impressive, and today that's one of the most effective ways of monitoring our boards or dams or tailings. A closer example, closer to us, because this is in Russia. It happened in 2016. There was a slide after 2 months. That's how it looked like. People were blocked down there, were very frightened. One more, which happened in 2016. That's how it looked in the photograph. Another example from Russia in 2024, one people got wounded, one died, and the investigation committee initiated a criminal case. The possible imprisonment up to 10 years. That's how it looked like. So one more case after this accident happened, there was a serious activity happened and 4 mines stopped their operations. Obviously, the costs would be very high. And these are open pits and open problems that we've learned about. And to learn how many similar accidents happen, we may just guess. I saw some small statistics in one of my colleagues' presentations. So what we do as GTX, we do geotechnical monitoring, and we are trying to maximize the efficiency because the strategy which companies use on CIS countries and Russia is different from the international practices. Companies prefer to establish their own department of geotechnics and buy their own equipment, and rarely they go for outsourcing. And talking about our services now, geotechnical radar monitoring is a new thing for CIS and Russia. We propose equipment for rent. Our experts would evaluate or assess all data, and we will help you to manage risk remotely. We have a geotechnical lab. We can talk about forecasting, not just the short-term plot when we analyze the radars, and we can talk about weeks or days. Using our geotechnical labs, we may make forecasts for the next couple of years. We can analyze data which are available today with your enterprise, and that's probably the most demanded service because the personnel problem is very common and very often don't have enough hands to make analysis. Consultations, consultancy services, and training, we can help you to develop your departments, to show you what is geotechnics in the way that we view it. Supply equipment. I'm not going to talk a lot about it, and we always provide technical support to users. In our team, there are no random people. Our team consists of colleagues who work with the major international brands presented in Russia until 2023. You are more lucky, you still have them. So we know what is georadar, we know what is geotechnical monitoring, and in order to highlight how it works here, these are international indicators showing selling of geotechnical radars. These are the achievements of our team until 2022. At different stages, we used to work with different producers and vendors. But these are our current customers that we've managed to communicate, work, or even make contracts with. Support professional community. If you are interested in geotechnical monitoring, you can subscribe to our Telegram channel, and we are sharing news there. Experts can talk to each other. And we see our solutions as comprehensive. This is the hardware that we offer to Russia and CIS. This is our flagship equipment, GeoRadar CFC now, made in China. It looks like that. It works under plus 55 and even under plus 60 degrees. And also it works under very cold temperatures. We may not cover it, unlike our European colleagues. We have our own development, which is MINEX, GeoSupport, and MS. This is a radar for particular conditions. We have optical equipment analog to scanning tachyometers of Leica or other scanners and INSAR monitoring. This is satellite monitoring, which enables to cover more territory. A bit of statistics. We started to operate in 2022. We had 8 RPI in 2023. The first supply we made at the end of 2023. Now, in the territory of Russia and CIS, we operate 23 radars. We are talking about our and Chinese solutions. Cases in Central Asia. To be more specific. And how it shows on this graph what equipment is needed in what situations. We must say these are not mutually exclusive equipment. These are the pieces of equipment which enable us to create a monitoring system at enterprises supporting the full safety cycle. And thank you for your attention. I would be happy to answer your questions.
Thank you very much, Monica. Sir? Now we have about 5 or 6 minutes for any questions from the audience here. Do we have any questions to our panelists? Well, maybe then I'll pose a couple to our to our esteemed panelists here. Firstly, Victor, in your experience, what are the key reasons that environmental and social management systems fail or don't work and lead to the kind of incidents that you described at the beginning of your presentation?
Спасибо, Анна. Да, на самом деле,
Thank you, Anna. Yes, indeed. Very often management systems don't work. We saw that in several examples, which led to serious environmental and social incidents. What I would like to tell you based on our experience. First of all, systems often are conditional. We can get a certificate just for the sake of a piece of paper to show our customers, exchanges, other stakeholders that we kind of have a certificate. We put it on the wall, and at that we stop. This is the pure formality. In reality, nothing works. Second point is the application of processes. It often happens that we have integrated management system, kind of independent organism, and everything needed according to legislation to perform that. And management, it's for stakeholders, investors, lenders, and so on. And it creates a big burden onto personnel and a big burden onto company in general, and that's absolutely ineffective. And the third thing is personnel competence, because in order to correctly manage all these matters that were discussed here, which I spoke about, a certain competence is required. If internal competence is insufficient, we can put someone to outsource, and there are some matters which must not be given to outsource. So you need to improve internal competence of your internal personnel. Here's another problem as excessively complex documents.
Also, very complicated documents is a problem. We make different guidelines and instructions for employees, and like it's not real for employees to learn it by heart and really to follow it. And it is the same with the processes on risk assessment, etc. So we must really simplify it, and it must be working tools. And I think very important, the most important, if you will look at key international standards, ISO and IFK and others. Well, first of all, it is being said about leadership and about support from the management cycle. And if it is not being supported, this process not being supported by leadership, then accordingly other departments they cannot effectively integrate these elements to the management system. That's why leadership and full support from leadership is key to success. Thank you very much.
Thank you. I think, yeah, you stress some very important points here that we see often in mining operations. We only have 1 minute left here, so there's one question there from Paki Boss, so please wait for a microphone. Thank you.
Thank you very much sharing your insights for tailing management and also the environmental impact assessment. And you mentioned about social impact assessments as well. Thank you very much. I would like to get your opinion, especially Sam and others also, if they can put their inputs. If the tailing dam failure happen, this is not affecting only one mine. It's affecting mining reputation. So then getting social permitting, government regulations becoming tight, and investors, of course, they are becoming reluctant to invest on mining. So from the last, I think, 5-6 years, you mentioned about 30 failures happened. What's the common similarities on these tailing dams failures? One, this question. Second is, what is the learnings? So with the new investment, for example, we have got lots of projects. So what we can take precautions, what precautions we can take at designing stage to prevent this kind of failures. So thank you very much.
Sam, do you want to take that?
Yeah, thank you. Yeah, very important question. Thank you very much. Regarding the reasons and of these failures, yeah, most of them just was due to, as I mentioned, internal erosion was important for all of them, which was initiating events for some of them, and then a slope instability as well, due to different reasons, including earthquake-induced just instabilities or liquefaction, or it could be due because of the flood-related or just difference in the fluctuations in the pool water pressure inside the embankments. Also, overtopping was the reason for some of them, for several of them. And how can we just prevent such events? As I mentioned, risk-based approach is for such situation when we don't know what the problem is. For instance, for the new designs, when we are going to design a new facility, we should just start from step one, design it to comply with all of to satisfy all of these criteria. For instance, the safety factor for the seismic events should be 1 point something, the safety factor for limit equilibrium analysis for the non-seismic loading should be this much, the maximum deformation should be this much. So we should tick all of the boxes from beginning. But the problem is for the existing facilities or old facilities, that it's not possible for all of the criteria will be satisfied in such facilities. It's a time that risk assessment is important. When we developed, there were several other slides behind after my presentation, so I didn't have time to just present all of them. If you follow the ANCOLD guidelines or even CDA, you should satisfy the all principles, which means the risk should be as low as reasonably practicable. So, what did I mention that? In all of this situation, we should use all of the supporting documents that we have, including, for instance, output from the stability analysis, from different deformation numerical analysis, from monitoring data, instrumentation. Also, we should do dam break assessment as well to just know what is the consequence category of the facility and how many fatalities we will have for different loading conditions. And if we have all of this information, we can develop the risk profile of the project, and then we develop the risk profile of the project for different failure modes, credible failure mode scenario. We will understand what is the most important risk to mitigate at first. For instance, we have when we do just traditional way or just a standard-based assessment, we know the safety factor is 1.2 for the normal scenario, drain scenario, while it should be 1.5. And at the same time, we have problem in our spillway, and at the same time, we have problem in our foundation. We don't know which of them is more important. But when we do the risk assessment and when we develop the risk profile of the project, you understand, probably that instability, if the safety factor for instability doesn't satisfy the criteria, it doesn't matter much, because at the end of the day, because of that reason, you are still under that threshold line. But that spillway problem, it will increase, it will just push that our risk profile above that threshold line. So it means we should just, the most important thing is that we should just define some mitigation options our spillway, and to see if it reduces the or if push the risk profile of the project below that threshold line or not. And then when we just do that, then we should go for the next credible failure mode and see which of them is more important and which of them has the more effect to reduce the risk of the project. Without the risk assessment, we can't comment on that. So it means the same as the example I mentioned at the beginning. It's like the normal health check. If you don't tick several boxes, you don't know which of them is more important. And if you go to doctor, they will do the risk assessment at first. So it says, so your heart is more more important than your legs probably. So you should just look after your heart at first and then do the rest of that. So it's exactly the same thing.
Thank you very much. I think that concludes our session.